most of the people get into business analyst or data analyst role, and then gradually they shift to data science kind of role. However, as you mentioned, if companies have budget and have a bigger team, there can be 2-3 other roles they can consider. And similarly, our candidates may also consider those roles. So which are they? So BI analyst or business intelligence analyst is another interesting role, which has large overlap with the data analyst or business analyst role. But primarily, these people, for solving the same kind of analytical problem, they use a lot of visualization and tools. And what are those most commonly used tools? Like, I'm sure you must have seen Tableau or Power BI. So when you want to do the analysis and automate it, create a chart or automated dashboard. For example, we said your earlier problem was deciding a marketing campaign. In that case, a data analyst or business analyst have to work on that ad hoc problem. But there can be certain things which are regular thing, your KPIs, that how many people came to my website, how much sales I had. So those are ongoing processes, for which it's probably better to have a dashboard where those numbers are automated. You can just go have a look in the morning and accordingly take other decision. So that is where BI analysts are very good with visualization, dashboard, and automation of that. Fifth role that I want to mention, which is coming up especially nowadays with the big data and volume of the data, is data or ML engineer. So whereas data scientists may know the model, probably they created the POC model for 1,000 users. And now you want to scale it to, say, for example, for Sony, we have many products where we have 100 million or 200 million users. So probably data scientists created the model for 1,000 users. Now, how do you scale it up for 100 million user? And God help you if you're working for companies like Google or Facebook, where you have billions of users hitting your app all the time, then it is a challenge of scale. It is a challenge of engineering, and data and ML engineer can really work together with data scientists to solve the problem. What will be their additional role? So they will be probably getting the data in the right format, create the data pipeline, do the data quality check, and also automate the model and scale up the model for production implementation. And this is another very good role in terms of salary or career growth. And I think this role will grow very fast. And last but not the least is a data science or analytics manager. So currently, for example, the role I am heading, I would probably call it a managerial role rather than a pure data scientist role. Because yes, I may do some hands-on work, but I have to manage a team of statisticians, research scientists, data analysts, etc. And I have to get the work done by them, right? And hence, once you progress, especially someone like you who have got very good business understanding, have an MBA degree, and now you have good understanding of analytics and data science, etc., probably then that person can progress to a managerial role within data science or analytics. So these 5 or 6 are broadly the most important roles. So based on the preference and the comfort level of the audience or the participants, you can consider a different role. Other than data scientists, there are a lot of other roles. Please explore and find a suitable one for yourself. Over to you, Andrew.
Yeah, I mean, that totally makes sense. I mean, as enterprises go across their data journey, right, or their AI journey, they're going to be in different phases, whether they're in exploration or they're just getting started. Maybe they've just done one implementation, or even to what you were talking about, Facebook and Google, full on maturity,
Absolutely.
Massive amounts of data, as well as all kinds of different algorithms and machine learning, implementations. Depending on where they're at in the journey, they may need to bring on these different roles, right? And there's different overlaps, but there's definitely a lot of room in the market for people to explore these different roles, right? So
Absolutely,
I think, you definitely highlighted even more areas that we can go into for not only our career but our own personal interests, right? I think another interesting thing that you brought up was kind of the data preparation perspective, right? Because if you don't have really good data going into your models, then you're not going to have very good predictions, or you're not going to have very good analytics and things like that. So that was really great. So how would you recommend people be able to have like fast development of some of these skills to maybe get into some of these areas, whether it be like books or websites or influencers we can follow or things like that? Of course, please everyone follow Dr. 𝘿𝙖𝙩𝙖, of course. But yeah, any tips would be wonderful.
Sure. Thank you, Andrew. That's a very good question. And I think it naturally follows from the discussion that we just have. So once we know that there are many different roles, now how do we build the skills and what resources can we use, right? So excellent question. Thank you for that, Andrew. So definitely, I think the way I see it, not just in case of data science career, but any career, or even if you're deciding your company's marketing strategy, I would take a very similar approach philosophically, right? So I'll look at where I am at X, and then I decide where I want to go, that is Y, right? And this is the path that I have to bridge. And my skills and experience will help me bridge this path, right? So for example, in my case, also what I did, for example, when I graduated, I did my PhD and joined corporate world. And then, 7-8 years back, I saw that data science was emerging as a very interesting new field. Then first thing I did is analyze where I am, what are the skills I have. Then I analyze for a data scientist or what are the skills I need to have, correct? And I saw, okay, these are the skills, computer science I have because I had that degree. Those of you who don't have probably need to develop that, right? And then I had some knowledge of statistics, but I had to brush it up. I saw there is a lot of development in ML. So I did some courses on machine learning to, upgrade that part of the knowledge. And business and domain knowledge, of course, as you work, I think the kind of experience you will get, nothing, no textbook or anything can, theory knowledge can never replace that. Andrew, 𝘿𝙧𝙧𝙚, you have been in the business, you know that very well. We probably read a lot of books, fat books during our, college days, but definitely with experience, we learn a lot about the business or the domain knowledge. Now, specifically, now I'll probably go on level deeper and say specific skills also within these broader skills and where can you learn them. So I initially mentioned about mathematics and statistics, but that's a very vast and broad area. So do I need to learn everything in maths and stats? Probably that is very good to do, but maybe too overwhelming for a lot of us. So I'll tell you specifically what areas of mathematics and statistics are very relevant for data science. So within mathematics, there are two areas you should learn at least the basics. And I'm sure many of us have learned during our college days or undergrad days, but we have not practiced and forgotten. And those two areas are, one is calculus, especially differential calculus or derivative. Because if you think at a very high level, every machine learning problem is an optimization problem. And what is optimization? Optimization is nothing but maximizing or minimizing a function. And when you try to, for example, maximize a function or minimize a function, derivative is the way to go. So you say first order derivative set to 0, second order derivative is less than 0, then it is function is maximized. And similarly, if first order derivative is 0, second order derivative is positive, then function is minimized. So that basic concept of derivative of differential calculus is very useful. Second area of mathematics that you should learn is linear algebra. Why so? Because most of the time when you are dealing with big data problem, we try to portray the data or represent the data in a matrix format, right? Or a vector. So you can say the output variable is a vector and input variable is a matrix of dimension, 1000 multiplied by 1 million or whatever. So you represent the data with matrix, and when you are multiplying matrix or doing other operation with matrix, having the knowledge of linear algebra. Linear algebra is nothing but, doing the operations with vector and matrices, right? So knowledge of that will be very essential, especially when you are dealing with a lot of data, big data problem, right? So if you know how to multiply two matrices in the optimized manner, it will save you a lot of cost, lot of time, lot of effort. Without that, probably if you just want to multiply two matrix or add two matrix, we'll write, simple for loop up across the rows, across the column, and that will not be efficient, right? So definitely two areas of mathematics, summarizing differential calculus, broad calculus, and linear algebra. And within statistics, you should definitely learn descriptive statistics, which deals with mean, median, mode, standard deviation, variance, etc. That's kind of basic. It is a must-have. Second is inferential statistics, where we interpret or we do the hypothesis testing, right? So we have some data about the past, that is descriptive statistics. But I want to create an hypothesis and I want to test it. For example, I say, if I invest more effort or time on LinkedIn, my ROI will go up. That's a hypothesis, right? Then I need to test it. So I need to have the knowledge how to test hypothesis. There are different probability distributions also involved there, right? But definitely knowledge of inferential statistics is very important. And last area within this umbrella is probability theory, especially when you're predicting the future. When you're saying predictive analytics, most of the machine learning we're using for predictive analytics. What will be my sales? What will be my cost? What will be my employee turnover, right? So all these are prediction problem, and future is always probabilistic. Future is never deterministic, right? So nobody could predict that COVID will come, and now that we are talking about Omicron and other things, we can predict that okay, probably there may be a third wave or fourth wave, right? But nobody certainly can say it will happen or not happen. So future is always probabilistic. So learn probability theory to get into deeper of predictive analytics. Now that is about mathematics, statistics. That is the foundation. In the computer programming, I learned C, C++, Java, etc. in those days. But for data science, currently Python is the popular choice. So definitely, if you have not learned any computer programming language, please do learn Python. Another option can be R. And definitely, there are a lot of interesting tools coming up even for the AutoML space. We'll probably have a demo of Newton, which I used and I personally really liked. So definitely after some time, probably Andrew or the team will show you about that. So either learn Python or some AutoML tool like Newton, or Google has certain tool like that. So that you can get your computer science or programming part done there. And of course, for business domain knowledge, reading some books will give you the starting point. But once you do a project or work in the industry, that will be the base point. And to answer the last part of your question, definitely if there are students who are attending the session, they can choose their elective or courses accordingly, probably can do a master's in data science or machine learning. But that is not the only way to learn. Nowadays, there are so many good resources. We all at any point of our career, even experienced people, can learn and gain the skills. And where can you learn? Definitely, if you want to learn the theoretical skills or conceptual knowledge, I would definitely recommend you to check Coursera and edX. They have courses from the top universities in the world. There are excellent courses from Stanford, Harvard, MIT, and I myself have done many such courses. So those will be taught by the actual professors of those colleges who are actually teaching those courses in Stanford or Harvard, right? So definitely do check them for theoretical and knowledge and conceptual knowledge. But those of you who are looking for more practical application side of the thing, I would also recommend that you check Udemy. Udemy has a lot of courses by practitioners who have been there, done that, and they give very good practical perspective to it, give you actual code, workbook to check and practice with. And last website that I want to mention about is DataCamp. So other websites that I mentioned, Coursera, edX, or Udemy, you can learn any subject. Data science is one of them, but you can learn history, geography, philosophy, whatnot. But focused on data science, there is this website called DataCamp, where again, you have a lot of good courses on Python, R, SQL, etc., which are primarily focused on only data science. So definitely these are some of the websites definitely you can check. And there are a lot of good material on YouTube as well. And definitely on LinkedIn and other websites also have a lot of influencers who are sharing a lot of good content. And I do also share on a daily basis a lot of free resources. So those of you who are interested, please feel free to follow. Over to you, Andrew.
Yeah, that's great. I think just having a quick breakdown of, hey, here are some of the potential skills that I need to understand to move towards a data science career is really cool. Like those are like the tips and tricks, like, hey, let me just go after those real quick, right? Instead of like spreading very wide and trying to learn all kinds of different things, right? So definitely appreciate kind of your domain expertise and like, hey, maybe just go after these ones. And then of course, here at Newton, we're helping, democratize artificial intelligence. So, those people who maybe aren't moving towards all of those mathematical skills, but maybe are focusing on the domain knowledge and can leverage the automated machine learning platforms in order to, get to the business problems quickly is really what we're, trying to help achieve. But it never hurts to, learn these skills and things like that as well. I thought it was interesting. You had mentioned Python as one of the, main, coding languages to go after. I've also heard that similarly, it can be leveraged in a lot of different ways, not only just in data science as well. So definitely appreciate those tips. And then also, those open source courses from Coursera, as well as DataCamp, very interesting. And I think to your point, YouTube is very interesting. Even, you know, in my past, I had a quick interest in, you know, creating, you know, video games, right? And you can go into YouTube and use Unity, and they'll just say, hey, this is the code you can copy and paste, and you can get a character running around quickly, right? So, you know, that theme of automation is very interesting, and as we move forward, over the next 5 years, we'll see more and more of these things becoming automated so that we can focus more on the business problem rather than, you know, just putting our heads down and coding and things like that. So definitely appreciate that. So those are kind of the hard skills, right, that we were talking about. What about some of the soft skills for data scientists? And, you know, is it important for them to develop those soft skills as well, whether it be, you know, leadership or critical thinking, et cetera?
Yeah, definitely. That's another very good question. And interestingly, in many places, people ignore it. And that's why, in spite of having all the, you know, hard skills, people suffer. So I'm very happy that you asked me that question. So of course, we discussed about the hard skill, and definitely in the job description or interviews, those will be checked time and again. But definitely, if you want to be successful in the field, there are probably 3 more skills which are more on the softer side, which I think are extremely critical. Now, what are they? First among them is communication, right? And I can't highlight it anymore, because as you understand, as a data scientist, suppose you are my business stakeholder and I don't understand what is your business problem, right? Then the whole project is doomed. At the same time, I have solved the problem. I have created an outstanding model using state-of-the-art deep neural network, but I am not able to convince you to put into production or use it for your use case. Then again, whole effort has gone down the drain. So communication is extremely critical, especially because as a data scientist or a leader of the team, you will work with very different kind of stakeholders. Some of them are business stakeholders who just care about the business ROI, right? So as a marketing head, you may say, hey, what is my marketing ROI? How many customers am I reaching? How many sales target am I fulfilling, right? So that's gonna be your KPI at the end of the day. Whereas when I'm working with a statistician, they want to use the state-of-the-art models, right? Research scientists, they want to publish paper in the top quality journals and, you know, conferences. When I'm working with the engineers, they want to build the best kind of system, which is very fast, scalable, you know, and whatnot. So you're going to work with statistician, software engineers, business people, research scientists. So it is extremely critical to communicate well with them, understand their world, and every such people have their own language, vocabulary, and the way they communicate things, right? So it is very important to understand and communicate well with the different stakeholders. So communication is definitely the most important soft skill. Second, especially in the business context, is problem solving. Because if you are doing a PhD in data science, you can choose an abstract problem like, you know, abstract algebra or, you know, theoretical physics problem and solve it for your life. It may even fetch you a Nobel Prize, right? But if you are employed by some organization and they are paying you money, they expect some return out of it, and you are there to solve certain problems, right? So at the end of the day, we are using the tools, technology, models, but to solve some business problem, get the ROI, get some business objective achieved, right? So definitely problem solving is a very important skill. And this is something that develops over a period of time as you practice more and more. So problem solving is second soft skill that people should learn. And third and most critical is continuous learning. Because this field is changing very fast. If we did this session 3 to 5 years back, probably I'll be discussing about very different tools and technology. When I joined my PhD degree, you know, we use a tool called SPSS, which was very popular at that point of time. In corporate, many people was using a tool called SAS. Some people were using MATLAB, right? And I remember in terms of computer programming at one point of time, I was using mainframe system to do the processing. Then we moved to the computers, and now we are trying to use cloud or AWS for the processing, right? So the tools and technologies that we are talking about have changed a lot, and this is going to happen in the future. So continuous learning is the way to go. Those who entered the field, don't think that I have done a course, I have learned Python, and that is the end of day. No. Today we have Python, tomorrow it may be Scala or Julia or something else, or as you mentioned, an AutoML tool like Newton may take over. So whoever is using the field, they should know the latest tools and technologies and hence continuous learning is very critical.
Yeah, that's really great. So just to highlight that, so communication skills, being able to work with, different business units, different stakeholders, absolutely. Problem solving, looking at what are the different, issues that we're experiencing, within the enterprise, and how can we overcome those, leveraging the data that we have, and how much data we have is enormous. And then the continuous learning and upskilling, absolutely fundamental, right? I mean, if we're not constantly, looking at everything that's available in the market, then we're going to fall behind and not be able to, make those, leaps in our career. So for sure, I think all of those, different soft skills are extremely important, and appreciate you highlighting those for us as well. And so what can accelerate a data science career next year even more, right? So maybe what tools could be available? Because I know you had mentioned, hey, we may be, coding with this language now, and here we're moving to these languages. So, what are the different tools, or what do you see as the future to help with us to accelerate our careers?
So as I said earlier, future is always probabilistic. It is not deterministic. So I can only predict with certain probability, but it's impossible to predict perfectly. But as per the data that I have, I definitely think Python is going to continue for quite some time. It will be there. Machine learning will be there for quite some time. Deep learning is having a lot of interesting use cases, especially in the area of image, audio and video and text data. So not non-numeric data, right? So those trends will broadly continue. But two specific trends that I see can have very good impact, right? One of them is move towards a cloud computing platform. And this is something happening very fast. So we see AWS is the leader there. Azure has also become very big. Google Cloud is also growing, right? So we don't need a computer. We don't need a storage. We can just get an account in the cloud. You log into your account, your data is there. You create your model, you deploy your model. Everything can be done in the cloud. So definitely those of you who are thinking of the future, especially 2022 and beyond, please do learn one cloud technology, maybe AWS or Azure. That will be immensely helpful to you. And second is something, and that's where I think Newton also comes into the place, is AutoML solution, right? And especially as you mentioned rightly, democratizing AI. Because a lot of things that today we mentioned, be statistics, mathematics, linear algebra, matrix multiplication, or probability statistics, may be very scary to a common citizen. And they should not be, they should not be kept away from this, development of AI and ML, right? And that is where I think a tool like Newton, or even not only Newton, Google also has an AutoML tool. I think there is something like iRobot and few others, but H2 also is doing pretty well, I believe, right? So this AutoML is a very interesting technology. I think, of course, it may not be able to solve all the problem where you need a lot of customization and new algorithm development from the scratch, but a lot of problems that we are solving are pretty standard. For example, a forecasting problem: how many PlayStations will sell in next few months? And same problem can be applied to a company like Target when you are trying to predict how many clothing item or electronics item will sell store. And the same can be case for a B2B company, say for your company, that how many customers or sales you'll get in next few months, right? So fundamentally, all these problems are a regression problem where you're trying to predict a continuous variable. Similarly, there can be a classification problem where you want to predict whether somebody will have COVID or not, right? Somebody will die or not, or somebody will get the particular job or not, right? It's a classification problem. So if your problem is very standardized and it is possible to codify the whole thing, AutoML tool like Newton can be extremely useful, I believe. I have personally used your tool. I found it really fascinating, especially for someone who is not coming with a lot of coding or statistical background. You just go enter the tool, and I'm sure after some time you'll show probably a demo, I believe. So, you'll be able to, I think audience will be able to see that you just go enter the tool, you upload your data, decide which is the prediction variable, which are the feature variable, will do the exploratory analysis for you, it will create the model, do the evaluation, give you the metrics, so and you are ready to go without knowing what is happening behind the hood. And that is something probably your team and your product has already taken care of. So I think definitely cloud and AutoML tool are some of the two interesting development that is happening, and that can really actually expand the field and also democratize it, as you rightly pointed out. And I think that is the future.